Greetings, got a request to do example 1.13. So I'm going to do a little short video here, try and explain the solution that they came up with, see if I can make it make more sense for you, okay? So what they gave us here are a null and an alternate hypotheses in the smoothed curve version. In other words, they're not doing them with a frequency plot like we did with bag A and bag B, but instead they're saying that the area under the curve represents the probabilities, okay? That's a key idea that hopefully you get from doing the reading. So bag A is the triangle plot given as HO, and bag B is the triangle plot given for H1 there, okay? So first thing they want us to do is determine whether this is one-sided to the right, one-sided to the left, or if it is two-sided, okay? Well, hopefully you see that the more popular stuff, let me get the right color here. Okay, so the more popular stuff that I want is given by, on the alternate, to the right of what is in the null. In other words, it looks like we're going which way? That way, aren't we, right? See, more common, more frequent in the alternate here. So this is going to be one-sided to the right. That's going to be our solution there. Okay. Now it says, consider the following decision rule. Reject the null if the selected voucher is $10 or more extreme. In the appropriate picture, shade the region of the corresponding significance level, clearly label it with the region with alpha, then calculate the value of alpha. Hint, you'll need to find the equation of the line represented by the hypotenuse of the triangle HO. Okay, well, it gives a huge hint here to tell us which distribution we're supposed to be doing this in the null, but we already know that because we're doing an alpha calculation. So let's say that $10 is roughly right about there-ish, okay? So this region right here that I'm shading in, that region is going to be alpha, okay? So that region right there represents alpha. And so what I need to do is I need to find the area encompassed by that. So what I need to do is I need to find the area of that triangle. Okay, so now what you need to recall, let's go ahead and switch to a blank here. In just a second, I need to get a new window going here. Let's see, I want to go to that window. Okay, so what you need to recall is that to find the area of a triangle is that the area of a triangle is given by 1/2 times the base times the height. So in the drawing that we just had there, here's our triangle that represents the null hypotheses. And what I need to do is I need to find out the area of this little red shaded region down here. So to be able to do that, I'm going to need to know what? Well, I'm going to need to know both the base and the height of this little red triangle. So in other words, I need to know what that height is right there, and I need to know what that base right there is. Okay, now I'll do the base. That's pretty straightforward. That number is 10. This number right here is 12, right? And so if that is the case, so we're going from 10 to 12, then we must see that the base has got to be equal to what? 2. That it's got a length of 2 there. Hopefully that makes sense. Let's go back to our screenshot here for just a second. See, we're going from 10 to 12. Actually, I should put the 10 in right here, shouldn't I, huh? And so that gives me this length right here has got to be 2. So now the $64,000 question is, what is the height? Now they give us a hint here and said you're going to have to go find out the equation of this line to be able to figure that out. Why? Well, because this height right here is going to give them y what? Well, it's the y value for that ordered pair right there. We know what the x value is. The x value is 10. And what we need to know is what is the corresponding y value, right? A little question mark there. So I get that y value by finding the coordinates to that point. Well, to find the coordinates to that point, I need to know the equation of the line. Okay, so to be able to do that, what we're going to start off with is find out what the slope of this line is. And to find what the slope of that line is, we're going to notice that it's what? The change in y over the change in x. That gives us the slope of a line, doesn't it? In other words, the rise over the run. So if we use that, then we see that what? We know this height right here on the line is 1/6, and then we know that our run here is equal to 12, isn't it, right? Okay, so that tells me that the slope of this line, first of all, just to remind you real quick, this is a downhill line, isn't it? This line is negatively sloped, so we know m is going to be negative here, okay? So m for this line is going to be equal to our rise, which we'll say is -1/6, divided by our run, which is 12, And then when we clean up that fraction, we get a negative 1/72, don't we, right? There we go. That's better. Okay, so m is equal to 1/72. Let's go back to the drawing for just a second here, and we see our y-intercept is at 0.16. Okay, so the equation of that line right there, this line right here, Stuggy right there, its line is y equals negative 1/72x plus 1/6. Okay, and that's a quick review of some rather important algebraic concepts that hopefully you recall from back in the day when you took algebra. We will be doing quite a bit of work with lines in this class, so if all that looks unfamiliar to you, then not a bad idea to grab your algebra book and go back and review it, okay? All right, now I need to know the coordinates of this point right here. I know what the x value is. The x value is 10. I need to know what the corresponding y value is. So to be able to get that, what I've got to do is I've got to go in and find out what the height is, and to figure out the height, well, I got to plug that into my formula here. All right, so that's y is equal to negative 1/72 times 10 plus 1/6, which is going to be equal to what? Well, let's see, that's going to be negative 10/72 plus a 6. If you do all the arithmetic out of that, you end up with 136. Okay, I'll let you do the arithmetic at that point. So that tells me that the height is equal to 136. So to find the area of that triangle, remember that alpha here is going to be equal to what? 1/2 the base times the height. Okay, well, we know what our base was. We already figured it out. We figured out the base is 2. So that's 1/2 times our base, which is 2, times our height, which is what? 136. Okay? And so when we multiply that all out, obviously we get back 136. And 136 is, as a decimal, is approximately about what? 2.8%. Actually, probably is exactly 2.8%. I just being lazy and looking at the book here, so letting it do the arithmetic for me. Okay, so that's how we figure out alpha. So how do we go out and figure out beta? Okay, well, to do beta, let's go back over to our original problem here. Notice that beta is calculated in the distribution of the alternate. So if, again, our cutoff value is 10, if that's our critical value, then we know that what? If alpha went to the right, then beta is going to go to the left. Remember that trick, that sort of survival technique I told you, is that when you're comparing the two plots, alpha and beta are always in opposite directions of each other, okay? But if you think about it intuitively, that makes sense, because look, if I'm actually holding bag B here, this is where I'm going to say it's bag A. Anything that I pick down in this direction, in other words, if I pick like say a 3 or a 4 or whatever, I'm going to say it's bag B, okay? Excuse me, I'm going to say it's bag A. Sometimes my tongue is my worst enemy. Okay, so again, that's at 10. And so what I need to do now is find the area of this red triangle right here. Okay, so let's go back over here to our drawing. Actually, let's go ahead and get a fresh one. Let me make a new one here for you. So we'll make a new palette to do this dog. Okay, all right. So now we're going to be working where? Well, we're in the distribution of the alternate. And so now our triangle looks not quite unlike, but similar to this, where that's at 12 and this is at 10. Okay, so we need to figure out the area of this triangle. Again, to figure out the base is going to be easy. It's simply this distance right here. So we know the base of our triangle is equal to 10, isn't it? Hopefully that makes sense. Okay, so to get this red shaded region here, again, we're going to have to use the formula to find the area of a triangle. So the area of a triangle is found by 1/2 the base times the height. So beta, which is that red shaded region right there, is going to be equal to 1/2 the base times the height. And again, I got to figure out the height by figuring out what that ordered pair right there is. Now again, my x value is equal to 10, and I need to know what the corresponding y value is. Now this triangle, just like the last one, has got a height of 1/6, okay? And so to find the slope here, or m, M is going to be, again, our change in y, which is 1/6 divided by our change in x, which is 12. But this time we have a positively opening line, so positive slope. So that's a positive 1/72. Okay? Now it's going through the origin, which means that our intercept is at 0, 0. So y is equal to 1/72 x plus 0 if you insist on putting it in, but you don't have to put that part in, obviously. Okay? All right, so to figure out what the height of our triangle is, our height is going to be equal to what? It's going to be 1/72 times 10, isn't it, right? Which is what? 10/72. We could leave it like that, right? So the textbook did. They just left it as 10/72 instead of reducing it. So we'll roll with that. So 10/72. We got to put everything into the pot here. So we got 1/2 times our base, which is 10, times our height, which is 10/72, which when I simplify that all is going to give me 50/72 as a fraction, okay, or as a decimal about, or excuse me, as a percentage about 69.4%, okay. So beta is pretty big. Alpha is relatively small, right? What do we get for alpha here? We got 2.8% for alpha, right? Okay, so now we got a couple more questions they want from us. Let me get to the questions here. Here we go. We just did that one. That was the beta. Okay, in the appropriate distribution, they also want us to shade the region that corresponds to 1 minus beta, the power of the test. Clearly label this region as a power and calculate the power of the test. Okay, so let's go back. Let's stay in here. Let's go back to our drawing. So if I want to do that, let's go and get I'm going to get green here, and we will shade that in as green, and that green region right there, we know that that's 1 minus beta. That is the power of the test. Okay, so that's 1 minus beta right there, which is going to be equal to what? Well, 1 minus beta is going to be equal to 1 minus 0.694, right? Which is going to be equal to what? About what? Roughly 0.360 or 30.6%. So that's about 30.6% if you do the arithmetic. Okay, so that's would be equal to the beta calculation right there. Okay, cool. All right, what's the next thing it want out of us here? Okay, I think I need to go back to the question here. Here we go. Okay, so the observed voucher is 3. In the appropriate picture, shade the region that corresponds to the p-value, clearly label this as the p-value, and calculate the p-value. Okay, so let's do that. So that's back in, I got to get to the right picture here, that's back in this distribution. It's in the distribution of the null. The observed value was a 3, so that would be right there. So the corresponding p-value, let's go ahead and do the p-value in blue. So this blue striped region right here, that would correspond to our p-value, okay? So that's the p-value right there. And again, how are we going to calculate that? Well, we're going to need the equation of our line, right? We're going to have to come back to this dog right here because we're going to need to know the height, okay? So the p-value, or p-val, is going to be equal to what? Negative 1/72 times x, x would be equal to 3, plus 1/6, okay? And that'll give us our corresponding value for the height of that triangle, which corresponds to the p-value, okay? And so once you do that arithmetic, which you came back up with, or which you'll come back up with here, is that is equal to 1/8. Okay, I'll let you do the arithmetic. I'm actually just stealing it from the book. I'm assuming they got their arithmetic correct here, which is 0.125 if you want to give that as a decimal, okay? Now, what's the base? Well, hopefully you come over here and you see, well, look, you got the difference between 3 and 12, which is going to be equal to what? 9, right? So, oh, my bad, excuse me. I made a slight tactical error. Excuse me. Sorry. This is not the p-value. That's the height. I'm getting ahead of myself. It's not the p-value yet. Sorry about that. Let's fix that real quick. This is what? This is just h. That's the height of our triangle. Okay, now we're going to do the p-value. My bad. Sorry about that. I'm sure you guys are throwing popcorn at the screen going, Mike, that's not the p-value. So what is the p-value? It's 1/2 the base. Well, the base was equal to 9 times the height, which is what? That's 1/8. Okay, and when you turn the crank on that and get it to spit it out, you're going to get what? 56.25%. Okay. All right, let's go back and see if we can answer some of these questions that they have for us. Okay, so give a decision. So what would we do based upon that? Well, we would decide at this point to do what? We would reject the alternate, wouldn't we? We would accept the null, right? Well, one way to think about that is what? We did not fall in the rejection region in the null hypothesis. We fell in the acceptance region. So what this tells us is to what? Accept HO, doesn't it, right? So we would accept the null. Now, they ask us a couple of strange ancillary questions, and they say, okay, what we want you to do is make a new decision rule, right? And make the new decision rule so that it's got a larger rejection region. In other words, expand the rejection region. In other words, move move your critical value so that alpha gets bigger, and then tell us what happens with beta, okay? So let's go ahead and make a new drawing here real quick so that I can show you that. Okay. So we'll just start over one more quick plot of the null hypotheses here. Get a nice clean one so that we don't have all the rest of that stuff in there. So here is HO, the null hypotheses. This was at 12. Now, they set the original decision rule to be at $10, but let's say I decide to change my decision rule and make the cutoff point $9. They picked 8 in the book, but hey, I'm going to go for a different one. I'll go for 9, okay? Now, if I do that, notice that now this corresponding rejection region right here, that's my new alpha, isn't it, right? Okay. Notice that if I come down here and I draw the distribution of the alternate, okay, what I'll see in the distribution of the alternate is that what's happened is that now, again with the 9 here, right? Let's come over here and get red again. And this is my new what? This is my new beta, isn't it? Okay. And what we see is that the new beta, I think they put stars on here, didn't they? They called that alpha star and they called this beta star, okay, for the new decision rule. We see that beta star is less than the original beta. It's going to be smaller. Why is that? Because alpha got bigger, okay? So your answer to the last question is that what? Is that the corresponding new beta would be less than the original beta. That's all you got to say. Okay, well, hopefully that gets you through that one. If you got any other questions, don't feel shy about posting questions to the forum. That's always a great place to post questions, okay?